Good morning, good afternoon, good evening, wherever you are. Um, Today I wanted to do a video that's a little bit maybe behind where it should have been, but I was able to actually spend a little bit more time planning this one. So I hope that you guys enjoy it. This could be a two-parter as well, depending on how this goes. So I might only get through two of them, and then we'll talk about the other two in the next video. But the thing I wanted to talk to you guys about was just some of the basics of proton neutron and how do they figure all this stuff out. Because one of the things I think is really cool is, just because it's chemistry or physics or biology, there's a lot of the experiments that aren't that challenging to understand and actually make a lot of sense. Yes, nowadays that it's 2020, almost 2021, it could be really crazy to think about with some of this machinery costing over $5 million just to run one test. That's not what they had back then. That's not what they had. They had simple tools and they were able to accomplish great things. So one of the first things I want to kind of talk about is just like the progression in time. So in 1803, John Dalton came out with his atomic theory. And there were a few postulates that came with that. Those being, one, matter cannot be created nor destroyed. That you probably know already. I can't just make a smoothie appear out of my hands, and I can't just make this pen vanish because I want it to. That doesn't work. Same thing with energy. Atoms are real. A long time ago, like they didn't really know what stuff was. And he kind of said stuff is made of smaller stuff. So if you think about all, the pieces of a car and that those things are made of smaller things, you could get down to some nitty gritty stuff. Just like the human body, right? The body is filled with organ systems, which have organs, which are made of tissues, which have cells, which have atoms, which proton, neutron, electron. And even those are made of stuff. So you could go down pretty far. The cool thing I like mentioning with matter cannot be created or destroyed. Imagine that this is a snow globe and it's on a scale. So you have a building, it weighs 100 tons. If you were to detonate the building, maybe for demolition, and you can see it's all sorts of different pieces, it'll stay 100 tons. All the dust, all that stuff together will kind of equal that. And again, that was in 1803, so 200-ish, 220-ish years ago. The next one was Thomson, which was about 94 years later. And he's the one who, as you guys know, came up with electrons. Here's what he did. He had a cathode ray tube, and again, his cathode ray tube experiment. And the cool thing that he kind of did was he had this electricity flowing through, and he had magnets. And there was a positive plate up here, and the negative plate was down here. Well, here's the thing. Opposites attract. So if this is clearly turning up toward the positive plate, well, that would imply that electrons are negative. Again, positive plate, negative things would have to attract that, aka it's repelling from the negative. Also, that they don't have mass. When he was flowing this electricity through here, we know lightning is energy. Lightning, you can't weigh lightning. Electrons, electricity kind of goes together. So that's where we also come up with the fact that electrons are negligible in terms of mass. And if there's a negative, there has to be a positive. I'm going to start the video there, and we're going to talk about Ernest Rutherford, because he's the one who discovered that positive thing. And I think you know what it is. See you in the next one.